In this video, I will talk about synthetic division. This method is an alternative for long division as long as the divisor is of the form x plus something or x minus something, where that something is a real number. Let's explain this method via this example 1. Suppose they ask you to divide 3x squared plus 4x minus 5 by this divisor x minus 2, which is of the form x minus something, right? So which means that we can apply this method. Okay, first thing you do, you draw a vertical line followed by a horizontal line up to here, and on the top here you're gonna write the coefficients of the dividend, this polynomial. So 3, 4, minus 5. In the corner here, you're gonna write the opposite of this number. So here, this is the number negative 2. We're going to write the number 2, opposite. Alright, next, you bring down the first number here, whatever it is. It's 3, so right here 3. Next we multiply 3 times 2, so multiply these two guys. I'm gonna write an arrow here and write multiply for you to remember. 2 times 3, 3 times 2 is 6. Place the result over here. Next you add these two numbers, add 4 and 6. 4 plus 6 is 10, so we write 10 here. Then you repeat the process again. Multiply 10 times 2. Place the result over here, 20. So now add these two guys. Minus 5 plus 20 is 15. Right? And then we stop because we are the last column, right? Now separate this number from the rest. Turns out this number is going to be the remainder of the division, 15. These two numbers over here will determine the quotient. How? This first number, 10, is going to be the constant term. This other number, 3, is going to be the coefficient of x. If you have more numbers, the next should be the coefficient of x squared and so on. So what's going to be the answer then for this division? Quotient Q will be 3x plus the constant term 10, and the remainder should be just the number 15. So there we have the answer. Three x plus 10, quotient, remainder 15. Now, this time this method worked beautifully because the divisor was of this form and the dividend was complete. Complete in the sense that it had the quadratic term here, the linear term, and the constant. What if they give you a dividend that is not complete? Well, I will explain that to you on the next example. Let's go to the next example then. But before we go to the next example, let me explain to you what is this idea of a polynomial being complete or not. Polynomial is complete if it has all its terms: constant term, linear term, quadratic term. For instance, this polynomial for x squared plus 2x minus 7 is complete. So this one, yes, complete. However, when you look at this polynomial 2x squared minus 5, this polynomial is not complete. It has the quadratic term, does not have the linear term, it has the constant, right? So this is not complete. Similarly, if you are given this polynomial 6x squared minus x, this polynomial is not complete because the constant term now is missing, right? It has the quadratic term, linear term, but constant term is not there, so complete, no. Now, however, whenever you're giving a polynomial that is not complete, you may add this term 0 times whatever is the variable that is missing to complete the polynomial. Look, 2x squared minus 5 is not complete, but 2x squared plus 0 times x, which is 0, right? Minus 5 is complete, right? It's right here in the bottom. Is complete. So the good news is that whenever you're given a dividend that is not complete, you can easily complete it by adding zeros, right? This way, 0x for this term, 0 for the constant term. So this guy is complete. So this will help us to go through the next example. Let's go to the next example now. Example 2, divide 2x squared minus 5 by x plus 3. Okay, when you look at the divisor, x plus 3 is of the form x plus something, so we can apply synthetic division. But before we do that, we should complete this polynomial, right? 2x squared minus 5 is not complete, but I can easily complete it by adding this term 0x plus 0x minus 5. And then the new division will look like this. X plus 3. Now we are ready for synthetic division. So as we did before, we start by placing a vertical line followed by the horizontal line up to here. We write on the top the coefficients of the dividend, 2, 0, minus 5. Over here at the corner we write the opposite of this guy. Opposite of the number plus 3 is the number negative 3. Okay, so we start by bringing this down 2, then we multiply these two guys. 2 times negative 3 is negative 6. We place the result here. Then we add these two guys, add 0 plus negative 6. Let's write this word add here. Please remember, is minus 6. Then we multiply again. Negative 6 times minus 3 is positive 18. And then we add these two guys finally to get the number 13. We separate the 13 from the rest because this guy is going to be the remainder, and this part, these two numbers, will determine the quotient. How? This way. Remainder will be 13 right from here. Sort of write this backwards. Negative 6 will be the constant term of the quotient, and this number 2 will be the coefficient of x. Again, if you have more numbers, the next will be the coefficient of x squared, and the next the coefficient of x cubed, and so on. So this should be 2x. And this guy should be the quotient. So this should be then the answer. Quotient 2x minus 6, remainder 13.